best. You can be the King Kong banging on your chest. You could be the
Now, the question looked out like this. In order to produce a potent and effective drug, a pharmacist decided to establish the relationship between what? Between the age, which is in year, and time in minutes. And time in minutes takes for concession of bleeding among 10 accidental victims. So we have the data. So this is the age and the time for the time it takes for the bleeding. Now we want to what? We want to check whether there is a relationship between the age and the time. We have the age and then we have the time. The first one we want to first of all use what? Spearman rank to what? To cross-check it. The first thing is we are going to rank X. Now, if we look at this, we want to rank X. This X, we want to rank X. Now, the first one, the list here is 15, which is taken 1. Now, followed by what? Followed by 19. 19 is ranked 2. Now, followed by what? Followed by 20. 20 is taking the rank of what? The rank of 3. Now, followed by what? Followed by 21. But if you look at 21, we have one 21 here, we have another 21 here. So we are going to what? So we should rank this one to 4, and we supposed to rank this one to 5. But it's the same value. That means 21 is not bigger than 21. So that means that we are going to have the first for 4 plus 5. The first rank should be 4, the second rank should be what? Should be 5. So we add them together, 4 plus 5, which is what? Which is 9, then divided by 2. So when we do that, we are going to have what? 4.5. The answer here is going to be 4.5. So the 4.5 here, we now need to take the rank of this. We take the rank of 4.5, then the same thing goes with it. This one will take the rank of 4.5. So that means that if we have for 21 here is 4.5, then for 21 here we also have 4.5. Then followed by 22. Now, if you remember we stop at rank 5. You know, when you add 4 plus 5 together, it will give us 9. We divide it by 2, so we stop at 5. So we continue from where we stop. So the 22 will take the rank of 6. So the 22 take the rank of 6. Now followed by what? Followed by 24. 24 will take the rank of 7. And then followed by what? Followed by 25. 25 will take the rank of 8. 27 will take the rank of 9. And then 29. 29 will take the rank of 10. Immediately you finish the ranking and you discover that your last number here, the last rank here, is not equals to the total observation. Let us check this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have total observation to be 10. But our last rank here is 10. Immediately you discover that your last rank is not equal to the total observation. Then you have to check your work again. Now let's look at the rank of y. Now the first rank of y here is we have 15. 15 take the first rank. Now followed by what? Followed by 16. 16 rank to the second. After that, followed by what? Followed by 17. 17 is ranked to 3. Then followed by what? Followed by 18. 18 is ranked to 4. Now followed by what? Followed by 19. But if you check here, we have 119 here, we have another 19 here. Like I told you the other line here. So we have 5, we have 6. So that means we have 5 plus 6 divided by 2. So if you do justice to this, 5 plus 6 is 11 divided by 2, we have 5.5. So that is why this one is taking 5.5 and this one is also taking the 5.5. Now, if you move further, then the next rank, our next rank is what? Is 7. You know, we stop at 6. 5 plus 6, we stop at 6. So the next rank will be 7. So the rank of 7, 21 is taking what? 21 is taking the rank of 7. Then followed by 22. 22 is taking the rank of what? The rank of 8. Then followed by what? 23. 23 is taking the rank of what? The rank of 9. And then the last one is 24, which is taking the rank of 10. So that means that we have the last rank to be 10. And the total observation here is what? Is 10. That means that what? We are correct. Now, the next thing we need to be the word is different. We want to find the difference between the rank X and the rank Y. So now, 1 minus 10 minus what? Minus 1. We're going to have 9. Now, followed by 1 minus 8. Sorry, 1 minus 9. We're going to have minus 8. 4.5 minus 8. We're going to have minus 3.5. 6 minus 5.5. We're going to have 0.5. 3 minus 5.5. square this. That's why we have this square. Remember from our Spearman Rank formula, we have 1 minus summation. We have 1 minus what? 6 summation this square. Now we're going to square this. When you square 9, we're going to have 18. So when you square 8, we're going to have 64. Then when you square 3 minus 3.5, we're going to have 12.25. When you square 0.5, we're going to have 0.25. When you square this, we have this. 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 And then when you square the last one here, when you square 2.5, we're going to have 6.25. So by the time you now add them together, that's the solution. By the time you add everything together, we're going to arrive at what's the answer? 270. So now that we've got in our 270, then we now go back to what? We go back to our formula for what? For the Spearman line. So we go back to our formula. So when we go back to our formula, we are going to our formula. From the formula we have what? We have 1 minus. We have 1 minus what? 6 summation d squared over what? Over n into n squared minus 1. Now we have 1 minus 6 times our summation d is 270. We have 270, then divided by what? Our n here is 10. So we have 10 raised to the power 2 minus 1. So from here now, we're going to have 1. If we multiply this by this, we're going to have 1,620. Now divided by 10 into 10 squared is 100 minus 1. Then we subtract 1. So we have 1 minus 1,620 divided by 10 times 99. So we have 1 minus 1,620 divided by 990. So by the time you do justice to it, we're going to have 1 minus 1.636363. So by the time you subtract, we're going to have minus 0.6364, which is our R. That means that in what you calculate it, that means that as our x is increasing, the y is reducing by what? By this, which is what? It is minus 0.6364. So by the time you square this, let's say I have the square of R. By the time I square this now, let's say I have the square of R. So by the time I square this, I'm going to have what we call the R square. So by the time you square this now, we're going to have the R square. Then the R square for this is telling us that the R square is expressed in percentage, which is telling us that the amount of variation that is what? That is in our independent variable that can be explained by the independent variable. That is other variation which is not factored into this can only be explained by the other percentage that is remaining. So now we are going to move to the next one, which is how we can calculate our R square using a Pearson correlation. Okay, so now we want to use a Pearson correlation method to find the correlation coefficient. Now we have our A, which is in X, we have our time, which is in Y, which is Y. Now look at this formula. This is the formula for Pearson. We have n summation xy minus summation x summation y, then divided by square root of n times summation x squared minus summation x squared times n summation of y squared minus summation y all squared. Now that means that we need what? We need to first of all get what is our xy. So now the xy means that this multiplied by this multiplied by this multiplied by this. So I have my xy to the base. So now the summation of everything here will give me this. Now the next thing from that formula is, what is my summation x? The summation x is addition of everything that we have here, which is this. Now what is summation y? The summation y is everything that we have here, which is what? Which is this? This is 194. Now what do we need again? We need the x squared. Now you square this. The square of every value here under x is what we have as x squared. So we have this for when you square 15 we have this, when you square 12 we have this, goes by that. Now the summation of everything here, we're going to have 5,123, then followed by 1 over y. We square y also. 15 square will give us this, 23 square will give us this. So when we square everything, the addition of everything, we're going to have 38446. So by the time we put everything inside this formula, our n is the number of observations that we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have our n to be 10 into bracket the solution of xy, which is this, minus the solution of x times the solution of y, which is 223 times what? 194. Then divided by the square root of what? The n is 10. Then our solution of x squared. Our solution of x squared is 5,123. Then minus what? We have a solution x all squared times our n here is 10. Then the solution of y squared is 3,146. Then minus is because of minus, then we have a solution of y, which is 194 squared. So by the time we do the numerator, we are going to arrive at minus 692. Minus what? 692. Then divided by square root of, when we do justice to this one, we are going to have 1,501. Then when we do justice to this, we are going to have 824. So by the time we use this to divide it, we have what? Minus 0.1, 0.622, which is what? Which is the correlation coefficient. If they ask you that what is the what, you should find the r squared. R squared is just what? You just square the square of this. That the square of this is our r squared. The square of this, we have r squared to the what? Minus 0.622 all what? All squared, which is going to give me, we have what? We have. So this one is going to be, I'm going to have 0.386844. So by now we convert this to percent, we are going to have 38.68%. And then, what is the interpretation for this r square? The interpretation for this r square, I've said it earlier on that the what? The total variation in our what? In our independent variable can what? Our dependent variable can only account for what? 38.68. Let me come again. The total variation in our what? In our independent variable, our dependent variable, which is also called response variable, can only explain for 38.68%. The remaining variation, which is what? Which is about the remaining variation, which is about 6.2%, can only be accounted for by other variable, other factors, which is not what? Which is not in this. So then after that, then we have our correlation coefficient, we have our r squared. So the next one now is we are moving toward the regression. Stay with us. Okay.